So in this video we will talk about some more problems from the SAT practice test number 8, section 4 calculator questions here, and we'll kick it off with 23. So in 23 they present us with this equation. They tell us that the equation models the number of members M of a gym T years after the gym opens. So if you've dealt with these types of equations before, these exponential growth equations, we typically would have the starting amount of something here. So the starting number of members of the gym is 1,800. And you can confirm that by putting 0 in place of T, and you're going to get an answer of 1,800 when you evaluate that. And then the value that's here is usually close to 1. 1.02 obviously is close to 1. If the number's above 1, that indicates growth. If the number's below 1, that indicates decay. Now, we have 1 plus 0.02. So what we have going on here, because of this 1.02, is we have 2% growth in the number of members of this gym every year. Now what they ask us to do is they ask us to decide which of the following equations models the number of members of the gym Q quarters after the gym opens. So what we simply have to do here is transition the variable that the equation's dependent on from time to quarters, and T is going to be equal to the number of quarters divided by 4, right? 1 quarter into the year is 1 quarter of a year. 2 quarters into the year is half of a year, 2 divided by 4. So Q divided by 4 is what T is equal to in terms of Q. And if you look at your options, you see some options that involve 4Q as the exponent. You see one where the exponent hasn't even been changed. You see some that have changed the growth rate as well. But all we need to do is transition the variable T to the variable Q. Nothing else about the equation has to change. Number 24 here gives us some information. I tried to take the information out of the paragraph and just kind of represent it in an easier to digest way. But what they tell us is that we've got a finale for a TV show, and viewers could either use social media or text messages to vote for their favorite 2 contestants. The contestant receiving more than 50% of the vote won. An estimated 10% of viewers voted, and 30% of the votes were cast on social media. It goes on to say contestant 2 earned 70% of the votes cast on social media and 40% of the votes cast using a text message. Based on this information, which of the following is an accurate conclusion? So what I decided to do is I decided to basically make a little two-way table. So I've got social media voting and text message voting for each of the 2 contestants, contestant number 1 and contestant number 2. They flat out tell us these numbers, right? They tell us that 70% of the social media votes went to contestant 2, and they tell us that 40% of the text message votes went to contestant 2. So these values that you see entered in blue that I've just highlighted, they told us about those right within that sentence of the problem statement. Now, the number that's here, 70% plus whatever's here, the rest of the social media vote, that has to add up to 100, and that must mean 30% of the people who voted on social media voted for contestant 1, and then 60% that voted by text message must have voted for contestant 1, using the same logic, right? The total number of text message votes also has to add up to 100%. So which of these is the appropriate conclusion? If all viewers had voted, contestant 2 would have won. Only 10% of the viewers voted. There's nothing we can really say. Such a small number of people voted. We're just going to have to kind of assume that A is not the most logical conclusion. Viewers voting by social media were likely to be younger than viewers voting by text message. I don't know, maybe. They don't say anything about age here. You know, that's not information that we would be able to to find by the numbers that they give us. If all viewers who voted had voted by social media instead of by text message, contestant 2 would have won. So if all viewers who voted had voted by social media instead of by text message, contestant 2 would have won. Well, if this 60% that voted for contestant 1 by text message would have voted for social media, they still would have voted for contestant 1, even though they're now voting through a different method. So I don't think it's option C. And if you look at option D, viewers voting by social media were more likely to prefer contestant 2 than the viewers voting by text message. And that is pretty obvious based on the information we see, right? Social media voters, 70% preferred contestant 2. Text message voters, only 40% preferred contestant 2. So it seems like option D is the appropriate option. That's the option that we're going with, because although some of the other things very well might be true, based on the data that we have, this is the one that seems like the best conclusion. So here we've got some data, population for Greenleaf, Idaho, year 2000, year 2010, so not a lot of people living there. And if you read the problem statement, the table represents exactly what we thought it did by reading the heading of it. The relationship between population and year is linear. Which of the following functions P models the population of Greenleaf T years after the year 2000? Well, if a relationship is linear, there's going to be a slope that is constant throughout this relationship. And so I went ahead and basically treated this like an ordered pair, treated this like an ordered pair, and did a slope calculation, change in y, or change in population function values. So change in population values divided by corresponding change in time. And you do have to make sure you end up with a negative value here. That should be pretty obvious. The coefficient of t in any of the options here is negative. Now in 2 of the options, and you see I've already crossed these out, we get negative 16. The slope that we end up with is negative 1.6. So we should be looking at a slope of negative 1.6. Now, which of these options, A or D, is going to be the one that we have to decide with? So it says that T is measured in years after 2000. Check out what happens if I put 0. 0 would be 0 years after 2000. Check out what happens if I put 0 here in place of this T. 0 minus 2000 is negative 2000. Negative 1.6 times negative 2000 is adding a lot onto this 8.62, which definitely isn't the case. Try it for 2010. Well, T would be 10 if we're in the year 2010. 10 minus 2000, negative 1,990 times this 1.6. So we're subtracting off a huge negative value to get the population in 2010. That's clearly not what happened. So if you look at option A, when I put 0 in place of T, gives me 862, the population in the year 2000. That's what it's supposed to do. If I put 10, the value that represents 2010, measured in years after 2000, putting 10 in place of T, 1.6 times 10 is 16. 862 minus 16 gives me the population in the year 2010. So we're definitely looking at option A for this answer. Next question here says, to determine the mean number of children per household in a community, Tabitha surveyed 20 families at a playground. For the 20 families surveyed, the mean number of children per household was 2.4. Which of the following statements must be true? Must be true. The mean number of children in the per household in the community is 2.4. Now, based on her survey, that is the case. But are there likely to be families without children at the playground? They're not going to get surveyed. They're not going to be part of the people Tabitha talks to if they're not at the playground. She only looked at the playground. So I don't think that option A is the one that's most likely to be true, or must be true. A determination about the mean number of children per household in the community should not be made because the sample size is too small. I mean, it depends on the number of families in the community. If there's only 25 families in the community, that's a pretty good representation of the whole entire community. 20 families is. So we don't know how many families are actually in the community, so I don't know that we can necessarily make any judgment about B just yet. We won't rule it out, but let's go ahead and read these other options. The sampling method is flawed and may produce a biased estimate for the mean number of children per household in the community. That one seems like it's tempting to choose because of what I argued in part A. They are not going to be talking to people who don't have children in their household if they go to a playground where there aren't likely to be families there who don't have children. So I would be tempted to pick C, but let's just read D and make sure C seems like it's the best one. The sampling method is not flawed and is likely to produce an unbiased estimate of the mean number of children in the household, I think we just said, it is flawed. They aren't going to be likely asking people how many children are in their household who have no children in their household at that playground. So that's a flawed sampling method. Let's see, B or C? I think we want to go with C. Let's go back and talk about part B again. So it's which of the following statements must be true? A determination about the mean number of children per household in the community should not be made because the sample size is too small. Well, like I argued earlier, we don't know how many families are in the community. If it's 22, 25, if they've asked over half of the families in the community, this might be a decent amount sample size. We just don't know that, right? So that doesn't necessarily have to be true. The one that has to be true is that this is flawed because you're not likely going to be asking people without children in their household how many children they have at the playground, because those families are not likely to be at the playground.